I'm Dr. Chris Masterjohn of chrismasterjohnphd.com, and this is episode 55 of Mastering Nutrition, part 3 of our series, Nutrition in Neuroscience.
This is Mastering Nutrition with Chris Masterjohn. Take control of your health, master the science, and apply it like a pro. Are you ready?
Welcome to part 3 of the safari through the leading textbook, Neuroscience, where I, as your tour guide, point out all of the stuff relevant to nutrition. In part 1, we talked about the basic mechanisms of how neurons communicate information from one place to another and the roles of nutrition in that process. In part 2, we talked about all the major neurotransmitters, the roles of nutrition in making them, metabolizing them, clearing them, making them function properly. In part 3, we are talking about our 5 senses: touch, sight, hearing, smell, and taste. The roles of salt, potassium, magnesium, calcium, and vitamin A in making those things happen. How touch can go wrong in chronic pain. Nutritional strategies to deal with chronic pain, both at the site of the pain and in how your central nervous system is interpreting it. The role of vitamin A in preventing night blindness and its very closely related role in setting your circadian rhythm. How vitamin K2, magnesium, and vitamin A could perhaps play a role in preventing some types of hearing loss. Capsaicin, the thing that makes hot peppers hot, and how it really is literally hot as far as your nervous system is concerned. The use of topical capsaicin to manage pain. A speculation about why some anorexics may crave spicy foods because they're missing the literal heat from low body fat levels and low metabolic rates. All this and much more in this episode. Remember, for this and all my other content, you can get early ad-free content with transcripts and other premium features at chrismasterjohnphd.com/pro using Mastering Nutrition as a discount code. Without further ado, here's a word from my sponsors, and then we dig into the 5 senses. This episode is brought to you by Ample. Ample is incredible. It's a meal in a bottle that takes a total of 2 minutes to prepare, consume, and clean up. 2 minutes. I'm not kidding. Now, I know what you're thinking. Anything that quick just has to be made of synthetic ingredients that you'd have a hard time pronouncing and wouldn't want to put into your body. But it's not. Ample is made entirely from natural ingredients and designed to provide an optimal balance between protein, fat, and carbs, as well as all the vitamins and minerals that you'd need in a single meal. There's no question that it's always best to sit down and take your time eating a home-cooked meal from fresh ingredients. But let's face it, oftentimes we just don't have time for that. If you live a busy life like I do and your goal is to get things done, you need quality fuel that you can get into your system quickly. Here's a great example where Ample is perfect for me. When I shoot videos, it takes hours to set up and break down all of my equipment. So I try to get as many videos shot in a day as possible. This prevents wasting a lot of time on setup and helps me conserve big blocks of time outside of shooting videos to get into a flow state where I can research something to my heart's content and spend all the time I need thinking about it creatively and analytically. But if I spend hours dealing with recording equipment plus hours spent preparing food, eating it, and cleaning up, there's no time left over to actually shoot any videos. So on recording days, I use Ample to maximize efficiency and focus on getting things done. Ample comes in 3 versions: original, keto, and vegan. And each version comes in 2 portion sizes, 400 calorie and 600 calorie. The 600 calorie original version gives me 37 grams of protein from a mix of grass-fed whey and collagen, which promotes satiety and flips my brain on. Its fat comes from coconut oil and macadamia nut oil. I like these oils because they're low in polyunsaturated fatty acids, or PUFAs, oils that promote aging and are usually loaded into the processed foods that most people eat when they need something on the go. The coconut oil provides some medium-chain fats to keep my energy levels up, too. The carbs, the vitamins, and the minerals all come exclusively from food sources like sweet potatoes, bananas, cocoa powder, wheat and barley grass, and chlorella. It's full of natural prebiotic fibers and probiotics to promote a healthy microbiome, and the gentle sweetness comes from a mix of honey, monk fruit, and stevia. I just mix it with water, drink it, rinse out the bottle, and boom, 2 minutes in, and I'm fully fueled and ready to face the next phase of the day. I first came across Ample when I met its founder and CEO, Connor Young, at PaleoFX a few years ago. Connor inspired me with his vision for Ample, which I anticipate will be much more than a meal in a bottle in the near future. I've become an official advisor to Ample, and I'll be helping Ample design scientific research that will lead both to an ever-improving Ample and, I hope, meaningful contributions to our understanding of how to use nutrition to help people be healthier and happier and perform better at the challenges that they care most about. As a listener to the Mastering Nutrition podcast, I've also worked out a special deal for you. If you use the discount code CHRIS15, you'll get 15% off your first order of Ample. To get your discount, go to amplemeal.com. That's amplemeal.com, 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 and use the code CHRIS15 at checkout. This episode is brought to you by Ancestral Supplements. Traditional peoples, Native Americans, and early ancestral healers believed that eating the organs from a healthy animal would strengthen and support the health of the corresponding organ of the individual. For example, the traditional way of treating a person with a weak heart was to feed the person the heart of a healthy animal. Modern science makes sense of this. Heart is uniquely rich in coenzyme Q10, which supports heart health. The importance of eating organs, though, is much broader than simply matching the organ you eat to the organ you want to nourish. For example, natives of the Arctic had very limited access to plant foods and got their vitamin C from adrenal glands. And vitamin C is important to far more parts of your body than simply your adrenals. In his epic work, Nutrition and Physical Degeneration, Weston Price recorded a story of natives who cured blindness using eyeballs, which are very rich in vitamin A. But now that we understand vitamin A, we know that we can get even more vitamin A by eating liver, making liver good for your eyes. Our ancestors made liberal use of organ meats both to be economical and to utilize their healing and nourishing properties. Animals in the wild do the same. Weston Price had also recorded a story of how the zoos in his era were capturing lions, tigers, and leopards, oh my, only to watch them become infertile in captivity. Researchers then observed what the lions did when they killed zebras in the wild. What they did was they went straight for the organs and bone marrow, leaving the muscle meat behind for the birds. But even the birds took what they could of the organs and bone marrow. Price reported that once the zookeepers started feeding the animals organ meats, boom, their fertility returned. The problem I often encounter, though, is that many people just don't like eating organ meats. Let's face it, if you weren't raised on them, it can be very hard to acquire a taste for them. That is where Ancestral comes in. Ancestral Supplements has a nose-to-tail product line of grass-fed liver, organ meats, living collagen, bone marrow, and more, all in the convenience of a gelatin capsule. For more information or to buy any of their products, go to ancestralsupplements.com. Ancestral Supplements, putting back in what the modern world has left out. All right, we have covered the neurotransmitters. Now let's look at some specific topics, some specific problems to solve, if you will. And the first thing that we'll talk about is pain. Now, pain is closely related to your sense of touch. You have a sense of touch that we think of when something touches the outside of your body, and that's technically tactile sensation, and we could refer to that as Interoception, meaning perceiving our environment. Then there's the closely related Proprioception, which is a sense of ourselves and the space that we occupy and the relation of one body part to another within the space inside of ourselves. Proprioception and Interoception, or tactile sensation, are both using very similar systems, and these are mediated by mechanoreceptors. Mechanoreceptors are receptors where a membrane stretching will open an ion channel that allows positively charged ions to flow through. So this is acting extremely similarly to neurotransmitter receptors. It's just that the stimulus for opening the ion channel is not a chemical. It is a physical mechanical process of the membrane that contains the receptor stretching. Proprioception just has same types of mechanoreceptors, but instead of being in the surface of our body, they are in our muscles to sense the length of the muscle, in our tendons to sense the tension that the muscle is placing on the tendon, and they're in our joints to sense our proximity to the end of our range of motion. If we compare tactile sensation in our skin to pain reception in our skin, we get a general model of the difference between this normal touch sensation and pain. So in the case of the mechanoreceptors that mediate tactile sensation on the surface of our body, we have specialized cells that have the mechanoreceptors that have a milieu that is designed to increase sensitivity and to decrease the threshold required to generate an action potential. By contrast, when we experience pain, we have nociceptors or pain receptors that are on unspecialized low sensitivity neurons where you need a much stronger stimulus to generate an action potential that will make its way into the central nervous system. And that kind of makes sense, right? If you just touch someone lightly on the hand, it's not going to hurt because of those specialized nerves with mechanoreceptors that are designed to be super sensitive. But if you keep pushing hard enough, you will hurt that person because now you start activating these pain receptors or nociceptors on the unspecialized low sensitivity neurons that only get activated when you have a great enough stimulus to overcome that threshold. There's two different sets of fibers. The first one, it generates first pain, which when it's weak, it causes tingling, and when it's strong enough, causes sharp pain. And then there's another set that is responsible for so-called second pain or dull pain. And this is a chronic dull pain as opposed to an acute, short, sharp pain. If you take that model, you can say that there is a similar comparison could be made for how we feel inner pain deeper in our muscles, for example, or in our joints and so on. So the first thing that I find nutritionally interesting is this textbook's discussion of capsaicin, the thing that's responsible for the sensation of hotness in a hot pepper. This is mediated by the vanilloid receptor, known also in the abbreviated form as TRPV1. This mediates pain not only in response to capsaicin, but in response to hot temperatures that are above 110 degrees Fahrenheit or 43 degrees Celsius. What I find fantastically amazing about this is that this is literally showing you that peppers are literally hot. So they're not literally hot in the sense of physics. Like the capsaicin is not actually over the temperature of 110 Fahrenheit. But they are literally hot in the sense of your nervous system and perception because the receptor that mediates pain in response to intense heat is the receptor that is activated by capsaicin. So another way to say that would be to say that capsaicin is hijacking the receptor that mediates pain in response to intense heat. But it's still the same sensation. Now, if you eat a lot of hot foods, you will develop a tolerance for the hot foods. It will take more of the hotness to make it feel like a hot food. That's because capsaicin downregulates the receptor. It's sort of like we talked about before, organophosphates cause paralysis by blasting your muscles with so much acetylcholine that they need to downregulate their acetylcholine receptors so that they aren't as easily stimulated and they get paralyzed. Similarly, if you eat a lot of hot foods, your hot pain receptors go down in your mouth and you are less sensitive to the capsaicin. Well, this logic has been used to use capsaicin topically to relieve chronic pain. The logic here is that something in chronic pain, something's wrong with your pain receptors. And so for some reason, whatever that pain stimulus isn't downregulating the receptor, but capsaicin will. And so you put the capsaicin on, it hurts because that's what capsaicin does, but the pain in response to capsaicin, for whatever reason, is more effective at mediating the downregulation of the receptor than whatever it is that's causing the chronic pain. You could think of this kind of like hormesis. Hormesis is the principle that's a little bit of something that is bad for you is good for you. And the reason is that if you have something that's bad for you, your body reacts to it by adjusting its defenses against it. In some senses, you could think of exercise as hormesis because you don't get strong from lifting weights. You get strong from going home and resting after you lifted weights. That's providing that stimulus that your body then reacts to with increased fitness. A better model of hormesis would be the polyphenols found in fruits and vegetables. Now, we all think of these, not all, most of us think of these as good for you, but the way that they're good for you is that they act as toxins, but they're the toxins that our bodies have been used to consuming and being exposed to in the environment for all of human existence. As a result, we are very well adapted to them. And when we consume them, even though they have toxic effects, like if you were to dump a buttload of these polyphenols onto a cell, you might kill the cell. Only a little bit of these get into our circulation and get into our tissues, and we react with greater antioxidant defense, greater detoxification capabilities, and so on and so forth. And so cigarette smoke does not appear to be hormetic because people that smoke get cancer from it. And so there is no known dose of cigarettes that you can smoke that is good for you. So you eat fruits and vegetables and they're toxic, but they cause a greater upregulation of the defenses than they do toxicity. You smoke cigarettes and it causes greater toxicity than upregulation of the defenses. So one is hormetic and one is toxic at those doses. So capsaicin is sort of like a reverse hormesis. What it's doing is instead of causing you to upregulate defenses, it's causing you to downregulate pain receptors. But it's the same, it's almost the same principle. It's just in the opposite direction. Now, there are several other things that I find very interesting about this hot receptor thing. And this relates to a conversation that I had with one of my friends and colleagues that I'll get to in a moment about cravings that anorexics can have for hot foods. Before I get to that, I have to talk a little bit about interoception. So in addition to exteroception, the sense of touch, tactile sensation, and proprioception, the sense of self and the space that we and our body parts occupy and their relation to one another, interoception is our sense of the physiological environment, the physiological state within the body. So if you look at where these pain receptors feed into the brain, they feed into the brain with information from other TRPs. So this was TRP V1. There are other similar receptors with TRP, denoted something else. One that responds to noxious cold, which is below 17 Celsius or below freezing. But then there are innocuous warm receptors and innocuous cool receptors. So altogether we have noxious heat, noxious cold, innocuous warm, innocuous cool. Then we have proprioceptors that sense itch, which have some overlapping, some of these receptors overlap with the pain response. And then all these different sensations of warm, hot, cold, cool get integrated along with information from lactic acid that's released during exercise and some of the other metabolites that could be released during tissue damage or intense exercise into a part of the spinal cord known as the anterolateral system. And the name for the integration of all this information is interoception, a sensation of the physiological state of the body. So I had a discussion with Brianna Theroux, who has been working for me for the last year and a half and recently opened her own business after completing her certificate in the psychology of eating. She's now doing coaching with clients, especially around the psychological aspects of managing your diet. You can find her at briannatheroux.com. I'll link to her site in the show notes. But what she said to me when we were talking about this was she's worked with anorexics who really crave spicy food. Could that be related? And it seems to me to make a lot of sense, because if the anterolateral system in the spinal cord is integrating hot, cold, warm, and cool with information about the body's temperature, and if your metabolic rate is going to decrease the generation of heat, and if your low body fat levels are going to decrease your insulation so that your body temperature actually does drop, then wouldn't that indicate cravings for the thing that activates the warm and hot receptors? And if capsaicin is activating the hot receptors, it seems like it could fit into a calculation in your spinal cord to sort of fool the sense of your body temperature in a way, by actually being calculated as literal heat in that center. So if you're anorexic and you have low body fat and you have low heat generation and you have low heat retention and your body is cooler, you crave the heat provided by that food because it literally is incorporated as information about temperature in your spinal cord. Besides topical capsaicin, what else might we do for pain? Well, we have to think about how we get overly sensitized to pain. And there's two different things going on. One in the peripheral nervous system, meaning outside the brain and spinal cord, and the other in the central nervous system, meaning the brain and spinal cord. In the peripheral nervous system, the primary things that are sensitizing your pain receptors are things that are released from inflammation and tissue damage. One of those is hydrogen ions, which is acidity. Acidity will sensitize the pain receptors. This might make a case for pH balance. When I think about pH balance, I think about measuring your urine pH. Probably it's going to be below 6 in the morning when you first get up, but most of the day, especially after your first meal, it should be in the 6s, probably between 6.4 and 6.8. And if it's not, you could try bicarbonate on an empty stomach, but when you do, start with a 1/4 teaspoon, measure your urine pH continually every time you pee until you get the dose and timing right. You have to see not only where does that amount of bicarbonate bring you, but also how long does the effect last. And that's one way to address urine pH. I found that my urine pH ran acidic until I corrected a zinc deficiency. So that's another thing to think about. But I don't know how important that would be, only because probably the major effect of acidity is going to be very local to the tissue damage. So while your systemic pH might alter a tiny, tiny bit in response to the bicarbonate, it might not have a huge effect at the local site of tissue damage. The second thing that I would try is to manage your manage the fatty acids that help you resolve inflammation. So I'm generally against anti-inflammatory things, and that's because I believe that most chronic inflammation is a result of not having properly resolved the inflammation. A lot of anti-inflammatory things, like most of the non-steroidal anti-inflammatory drugs, will lower your peak inflammation, but they will actually promote long-term chronic low-level inflammation because they also prevent you from resolving the inflammation. Arachidonic acid from liver and egg yolks is necessary for the initiation and resolution of inflammation. The omega-3 fatty acids, especially DHA from fish or algal oil, to a lesser extent from pastured egg yolks and maybe pastured butter fat, but primarily from fish or algal oil, is going to be the thing that's missing for a lot of people because a lot of people get enough omega-6 arachidonic acid and they don't get enough of the omega-3. So if you don't include omega-3 fatty acids in your diet, including them may help. There's a product from Metagenics called Specialized Pro-Resolving Mediators, or SPM. I haven't seen this studied, but what it's doing is it's providing the actual compounds that you make from the fatty acids, and that might help jumpstart the process of resolving inflammation. If these things don't work, then I think another way to try to jumpstart the resolution of inflammation would be, and I advise more caution about this, and make sure you talk to your doctor if there's any possibility that you might have negative reactions to aspirin. But in this approach, I would combine aspirin with fish oil and glycine along with the pH protocol for the urine with bicarbonate that I had just mentioned. And here's the logic. Although most non-steroidal and anti-inflammatory drugs, most over-the-counter anti-inflammatory drugs, including acetaminophen, which is not technically called an NSAID, but has similar concerns. Most of them block the production of resolvins that resolve inflammation. Aspirin, on the other hand, actually promotes the production of resolvins, and the EPA in the fish oil is only converted into resolvins in the presence of aspirin. Now, this is something that is very unique about aspirin, which is acetyl salicylate. The effect is from the acetyl part of the aspirin, not from the salicylate. And so you cannot mimic this with the natural salicylates that are found in foods, because foods do not contain acetyl salicylate. Also, one of the things that worries me about aspirin is that after the acetyl group acetylates the COX enzyme, which causes it to make the resolvins, it leaves behind salicylate, which actually can decrease the amount of the COX enzyme available. And so while you're making the COX enzyme make resolvins, you're also decreasing its expression, which seems like you're shooting yourself in the foot with that. So I think what you really want to happen with the aspirin is that you want to acetylate the COX enzyme, make the resolvins from the omega-6, the omega-3, the EPA, the DHA with the fish oil, and then you just want to get rid of the salicylate altogether. How do you get rid of salicylate? The most important thing is your urine pH. By bringing the pH of your urine from 6 to 7, you'll increase the rate at which you get rid of salicylate 17-fold. If you bring your urine pH up to 8, you increase the removal of salicylate through your urine 25-fold. And then the glycine is because glycine will quickly metabolize the salicylate into the glycinated form that is detoxified more easily and is inactive. I don't know how much to dose this because there just isn't adequate data. But what I would do is the aspirin, I would start with the lowest dose of baby aspirin and work your way up slowly. And the fish oil, I would dose at maybe 1 to 3 grams of omega-3 fatty acids a day. And the glycine, I would say probably shoot for 3 grams with each time that you take the aspirin. Now, the downside, apart from the potential to thin your blood, of course, is that a certain percentage of people react to aspirin with asthma. And in self-reported use, only about 1 or 2% of people make this complaint. But when they give people aspirin in a controlled setting and measure asthmatic responses in a laboratory, it's actually like 10 or 20% of people that respond to aspirin this way. And I think that's because aspirin uses glycine in its detoxification and depletes glycine. And glycine is involved in the synthesis of glutathione in the lung, which is your primary bronchodilator. So I think including the glycine in this protocol I suspect will prevent any risk of developing asthma in response to the aspirin. So I wouldn't jump to this particular thing, but I think if you're in a lot of pain and you're looking for a fairly natural root cause way to go about clearing it up, then I think after you try some of the more gentle measures, like improving your omega-3 fatty acid intake, then this aspirin plus fish oil plus glycine plus bicarbonate protocol might be worth trying. That's for peripheral sensitization to pain. For central sensitization to pain, part of the way you become sensitized is in an LTP-like process. Remember, long-term potentiation, or LTP, increases the sensitivity of a pathway, and it's mediated by NMDA receptors. And what happens, what theoretically can happen, is that if you don't have enough magnesium, the magnesium is not blocking the NMDA receptor. And so the NMDA receptor is inappropriately activated, and that gives you a greater LTP-like response to reinforce the pain pathway than you would otherwise have if you had adequate magnesium. So addressing a magnesium deficiency might help. Additionally, inadequate inhibitory signaling from glycine and GABA could be involved. And glycine and GABA supplementation could help. But remember, if the case is loss of the proper chloride distribution, glycine and GABA theoretically might not help, or maybe even might make it worse, in which case addressing electrolyte imbalances and energy problems might help restore the function of glycine and GABA. The endocannabinoids have anti-pain effects, and so arachidonic acid and DHA, like I had talked about before in that section, might also help. And of course, if endocannabinoids help, then cannabinoids from cannabis might also help, and that might be a rationale for using CBD oil. So that was a longer discussion of touch and its relation to pain. Let's go through some of the other senses to look at how nutrition can be important in basic perception of our other senses. These sections will be shorter. So in vision, light is focused by many of the parts of our eye on our retina. The retina is the innermost, meaning the most to the back layer of the eye, and the retina is considered part of the central nervous system because of how it arises in embryonic development. Within the retina, there are photoreceptors known as rods and cones, as well as several other cell types. Usually in a neuron, the default state is to have the membrane polarized, and in response to a receptor activation, if you meet a certain threshold of depolarization, you generate an all or nothing action potential. In the photoreceptors, several of these things are reversed. So first of all, the default state is to be depolarized. And in darkness, there is a constant activation of neurotransmitter in response to that darkness in the default state. Light actually suppresses the release of neurotransmitter, but it doesn't do so in a threshold-mediated way. In other words, it's not an all-or-nothing deactivation of the neuron. Rather, there's a graded decrease in transmitter release in response to a graded increase in light within an individual photoreceptor. In darkness, we have a constant production of cyclic GMP. Cyclic Gmp is a nucleotide like ATP. ATP is adenosine triphosphate. ADP is adenosine diphosphate. AMP is adenosine monophosphate. GTP is guanosine triphosphate. GDP is guanosine diphosphate. GMP is guanosine monophosphate. GMP can be processed to form into a ring structure called cyclic GMP. And this is an example of a second messenger system. The cGMP activates a channel in the membrane that imports sodium and calcium. Because positive charge is coming into the cell, the default state is depolarized. There's also a channel that's independent of cGMP that lets potassium go out. And that potassium export just is not great enough to overcome the depolarizing effect of the sodium and calcium import. But it becomes relevant when the cGMP signal is lost. When light comes into the photoreceptor, it strikes a photopigment that contains an opsin protein and retinal, which is a form of vitamin A. The role of the opsin protein is to tune the retinal, the vitamin A, to react to a specific band of light wavelength. When the retinal absorbs a photon within that band of wavelength, it converts from 11 cis retinal to all trans retinal because one of the double bonds within the molecule breaks. That is a form of isomerization. Same molecule, different conformation. The isomerization of the retinal, the vitamin A, activates a protein called transducin. Transducin activates a phosphodiesterase that hydrolyzes cGMP, breaks it apart using water. Because the cGMP is lost, and the cGMP is normally what keeps the calcium-sodium importer open, to the extent the cGMP is lost, the calcium-sodium importer closes. That leads to a loss of the depolarizing default state. The potassium export channel stays open, leading to a hyperpolarizing of the cell. The reason you have this cascade, the reason that you have transducin and then the phosphodiesterase and making it complicated like this is because it allows amplification. The isomerization of one retinal molecule can activate as many as 800 transducin molecules, each of which can hydrolyze 6 cGMPs, which translates altogether into a closure of 200 ion channels, or 2% of the ion channels in the membrane of the photoreceptor, for each time that a photon is absorbed by retinal or vitamin A. That slows the release of neurotransmitter, which translates into a signal that travels down the optic nerve into the brain. Meanwhile, there's an immediate effect to shut down that transduction pathway as soon as communication from one photon makes its way up the optic nerve. What happens is, on the one hand, there's an enzyme that phosphorylates the opsin protein, preventing it from activating transducin anymore, and the all-trans retinal transfers back to a patch of cells known as the pigmented epithelium, where inside these cells, they'll convert the all-trans retinal back to the 11 cis retinal, and then shuttle it back to the photoreceptor with a binding protein. All of this is best studied in rods, which are responsible for the perception of basic outlines of shape in dim light. And in here, we see the opsin protein called rhodopsin. But in cones, which are responsible for color vision, we have red opsins, green opsins, and blue opsins that mediate RGB color vision. On top of all of this, we have the least studied one, which is in specific cells called intrinsically photosensitive retinal ganglion cells, or IPRGCs. We have an opsin known as melanopsin. And melanopsin acts in just the same way, but instead of translating light into vision, it translates the effect of blue light into a signal that tells our brain that it's daytime out. And this is responsible for our circadian rhythm, our body knowing when it's daytime and when it's nighttime. No one really knows how melanopsin is prioritized in this scheme. But one thing is very clear, that the cones get priority over vitamin A during vitamin A deficiency. And the reason is that it's utterly devastating to lose the ability to see during bright daylight in full vision, but it's not that bad to lose your night vision. And if you think about this outside the context of artificial lighting, this should be super obvious. Before artificial lighting, when did you do all your survival critical tasks? During the day. Even now, it's devastating to lose daytime vision. You are legally blind if you have something that compromises your daytime vision. If you have night blindness, you just need to turn your high beams on at night. Or, it's a problem, but it's nowhere near as devastating as losing your daytime vision. And the logic here is that with a limited vitamin A supply, if you have to lose part of your vision, you're going to lose your ability to see in dim light when it's less survival critical, and you're going to preserve your ability to see in the daytime. If you have night blindness, there's probably a 95% chance that you need more vitamin A in your diet. Sometimes it's zinc, but night blindness is a huge giveaway of a potential vitamin A deficiency. Vitamin A does other things that maintain the eye, like it prevents dryness in the eye. It promotes the immune defense in the eye. And there are much worse things that can happen to your eye if you're severely vitamin A deficient. But if you're just a little bit deficient, night blindness is often the first thing to happen. Now the question becomes, what is more survival critical? Having a well-working circadian rhythm or being able to see in dim light? Is it possible that the first thing to go is actually your circadian rhythm? I don't know the answer to that. But if you have problems in training your circadian rhythm with standard approaches, like put blue blockers on at night and get morning sunlight, and do these at a very consistent time of the day, if things don't help you get on a rhythm where you're getting tired and falling asleep at the same time every day and you're waking up at the same time every day, then something's missing in how the light is communicating to your brain, and vitamin A could be part of the problem. So that's how we see. What about how we hear? Well, inside our ears, we have hair cells that have tiny cilia-like hairs that protrude into a chamber that is very sodium poor and potassium rich. The hairs are graded in height so that you have one hair that's short, then you have one that's a little bit higher, one that's a little bit higher, one that's a little bit higher, and then in the back you have the highest hair in each cluster. And that's so that they can detect movement in a directional manner. They can detect movement that goes towards the tallest hair or away from the tallest hair. When the movement goes towards the tallest hair, it opens a potassium channel, and when the movement comes away from the tallest hair, it closes the potassium channel. The cell body of the hair cell is exposed on the other side to a second chamber that is very rich in sodium and poor in potassium, like most other extracellular fluids. When potassium enters the hair cell, that depolarizes the membrane. The depolarization of the membrane opens a voltage-gated calcium channel that causes calcium to come into the cell body, and that triggers neurotransmitter release. Depolarization also opens voltage-gated potassium channels in the cell body, and calcium opens calcium-regulated potassium channels in the cell body, and those together allow potassium to leave the cell into the potassium-poor chamber, leading to repolarization. So to visualize this, think of this stack of hairs of graded height. On the top, you have potassium-rich fluid, and on the bottom, you have potassium-poor fluid. The potassium first flows in to depolarize, and then it continues down into the bottom chamber to repolarize. And that's how you get movement coming in to move the hairs that leads to neurotransmitter release. And as soon as that movement stops, the repolarization resets everything. So, notably, you need enough calcium and potassium for your hearing to work. And although I don't know any evidence that not getting enough potassium in your diet compromises your hearing, maybe it does, and there is some evidence that certain subsets of the genetic defects that cause hearing loss do so by compromising the transport of potassium between cells. There are many causes of hearing loss, but among them, there is atherosclerotic damage to the microvasculature, the small blood vessels that nourish the ears, and there is ossification of the inner ear bones, meaning they get jammed up with too much calcium. That could indicate a role for vitamin K2, magnesium, and maybe vitamin A, since these nutrients are known to prevent calcium from getting into the wrong places. On the topic of vitamin K2, this is something that's found in animal fats and fermented foods, and I have a very in-depth analysis of vitamin K2 called the Ultimate Vitamin K2 Resource at chrismasterjohnphd.com/K2. A link to that, as well as resources on magnesium and vitamin A, calcium and potassium, all important to hearing, in the show notes. Moving on to smell. There are 950 odorant receptor genes in humans. About 40% of them are expressed. The others are pseudogenes, meaning genes, but they don't actually express a protein. So we have altogether about 400 different odorant receptors. And these are expressed in a way that each neuron in the olfactory system expresses only one specific receptor. Some of those receptors are highly specific to one chemical. Some of them are rather broad in their specificity. But this allows us to have relatively specific senses of smell for thousands of different things. The olfaction mechanism, the mechanism of our sense of smell, is very similar to how light affects the photoreceptors in the eyes. But instead of a photon in general turning down transmission, a highly specific odorant molecule binds to a receptor to turn up transmission. So it's sort of the reverse of what happens in the eye. An odorant binds to a receptor, which activates a protein called G-sub-Ulf. Some jokester named this, so it's spelled golf. It activates adenylate cyclase, and that causes you to take AMP and make cyclic AMP. That activates a channel that brings sodium and calcium into the cell. The calcium activates a chloride channel that, in this case, lets chloride out of the cell rather than in. All of this which depolarizes the membrane, and that leads to action potentials that reach the brain and release glutamate there. And then there's taste. We have taste buds on our tongue, on our palate, on our epiglottis, and our esophagus. And these taste buds have taste cells. These taste cells have microvilli, which are very small finger-like projections that have taste receptors. Unlike the 400 odorant receptors that we have just 5 classes of taste receptors. Tastes for salty, sour, sweet, bitter, and umami. In the case of salty and sour, we have salt, or the hydrogen ions from the acidity of the sourness, that travel right through the ion channels. So instead of something activating an ion channel to open, the ion channels are just open and the ions directly flow through them, and that's what transmits the taste of those signals. In the case of sweet, bitter, and umami, we have them binding to receptors that generate some kind of intracellular process to allow an influx of calcium to act as a second messenger. In both cases, depolarization of the membrane lets calcium in to release neurotransmitters, and the neurotransmitters are not exactly worked out for all of them, but GABA, ATP, and serotonin are all thought to play important roles in taste perception. This episode is brought to you by Ancestral Supplements. Traditional peoples, Native Americans, and early ancestral healers believed that eating the organs from a healthy animal would strengthen and support the health of the corresponding organ of the individual. For example, the traditional way of treating a person with a weak heart was to feed the person the heart of a healthy animal. Modern science makes sense of this. Heart is uniquely rich in coenzyme Q10, which supports heart health. The importance of eating organs, though, is much broader than simply matching the organ you eat to the organ you want to nourish. For example, natives of the Arctic had very limited access to plant foods and got their vitamin C from adrenal glands. And vitamin C is important to far more parts of your body than simply your adrenals. In his epic work, Nutrition and Physical Degeneration, Weston Price recorded a story of natives who cured blindness using eyeballs, which are very rich in vitamin A. But now that we understand vitamin A, we know that we can get even more vitamin A by eating liver, making liver good for your eyes. Our ancestors made liberal use of organ meats both to be economical and to utilize their healing and nourishing properties. Animals in the wild do the same. Weston Price had also recorded a story of how the zoos in his era were capturing lions, tigers, and leopards, oh my, only to watch them become infertile in captivity. Researchers then observed what the lions did when they killed zebras in the wild. What they did was they went straight for the organs and bone marrow, leaving the muscle meat behind for the birds. But even the birds took what they could of the organs and bone marrow. Price reported that once the zookeepers started feeding the animals organ meats, boom, their fertility returned. The problem I often encounter, though, is that many people just don't like eating organ meats. Let's face it, if you weren't raised on them, it can be very hard to acquire a taste for them. That is where Ancestral comes in. Ancestral Supplements has a nose-to-tail product line of grass-fed liver, organ meats, living collagen, bone marrow, and more, all in the convenience of a gelatin capsule. For more information or to buy any of their products, go to ancestralsupplements.com. Ancestral Supplements, putting back in what the modern world has left out. This episode is brought to you by Ample. Ample is incredible. It's a meal in a bottle that takes a total of 2 minutes to prepare, consume, and clean up. 2 minutes. I'm not kidding. Now, I know what you're thinking. Anything that quick just has to be made of synthetic ingredients that you'd have a hard time pronouncing and wouldn't want to put into your body. But it's not. Ample is made entirely from natural ingredients and designed to provide an optimal balance between protein, fat, and carbs, as well as all the vitamins and minerals that you'd need in a single meal. There's no question that it's always best to sit down and take your time eating a home-cooked meal from fresh ingredients. But let's face it, oftentimes we just don't have time for that. If you live a busy life like I do and your goal is to get things done, you need quality fuel that you can get into your system quickly. Here's a great example where Ample is perfect for me. When I shoot videos, it takes hours to set up and break down all of my equipment. So I try to get as many videos shot in a day as possible. This prevents wasting a lot of time on setup and helps me conserve big blocks of time outside of shooting videos to get into a flow state where I can research something to my heart's content and spend all the time I need thinking about it creatively and analytically. But if I spend hours dealing with recording equipment plus hours spent preparing food, eating it, and cleaning up, there's no time left over to actually shoot any videos. So on recording days, I use Ample to maximize efficiency and focus on getting things done. Ample comes in 3 versions: original, keto, and vegan. And each version comes in 2 portion sizes, 400 calorie and 600 calorie. The 600 calorie original version gives me 37 grams of protein from a mix of grass-fed whey and collagen, which promotes satiety and flips my brain on. Its fat comes from coconut oil and macadamia nut oil. I like these oils because they're low in polyunsaturated fatty acids, or PUFAs, oils that promote aging and are usually loaded into the processed foods that most people eat when they need something on the go. The coconut oil provides some medium-chain fats to keep my energy levels up, too. The carbs, the vitamins, and the minerals all come exclusively from food sources like sweet potatoes, bananas, cocoa powder, wheat and barley grass, and chlorella. It's full of natural prebiotic fibers and probiotics to promote a healthy microbiome, and the gentle sweetness comes from a mix of honey, monk fruit, and stevia. I just mix it with water, drink it, rinse out the bottle, and boom, 2 minutes in and I'm fully fueled and ready to face the next phase of the day. I first came across Ample when I met its founder and CEO, Connor Young, at PaleoFX a few years ago. Connor inspired me with his vision for Ample, which I anticipate will be much more than a meal in a bottle in the near future. I've become an official advisor to Ample, and I'll be helping Ample design scientific research that will lead both to an ever-improving Ample and, I hope, meaningful contributions to our understanding of how to use nutrition to help people be healthier and happier and perform better at the challenges that they care most about. As a listener to the Mastering Nutrition podcast, I've also worked out a special deal for you. If you use the discount code CHRIS15, you'll get 15% off your first order of Ample. To get your discount, go to amplemeal.com. That's amplemeal.com, 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 and use the code CHRIS15 at checkout. If you liked this episode and missed parts 1 and 2, go back 2 episodes to see parts 1 and 2. Part 4 will be out next week. If you don't want to wait for part 4, you can sign up for the CMJ Masterpass at chrismasterjohnphd.com/pro, where you can get early access to content, including part 4 right now, ad-free content, and transcripts and other premium features. Say hi to me somewhere on the internet by leaving a comment on that Facebook, YouTube, Instagram, and Twitter. Maybe I'll see you there. If not, I'll see you here in the next episode.